Today we are going to learn about mastering custom NER models with SpaCy. We will explore how to create, train, and deploy custom NER models tailored to specific domains, enhancing entity extraction accuracy. Welcome to our video on mastering custom named entity recognition models with SpaCy. In this session, we'll delve into the powerful capabilities SpaCy offers for creating and training custom NER models. Custom NER is essential for tailoring entity recognition systems to specific domains, significantly enhancing the accuracy of entity extraction. Throughout this video, you'll learn how to set up your SpaCy environment, create and annotate your dataset, train a custom NER model, and deploy it effectively. By the end, you'll be equipped with the skills to build and maintain your own NER pipeline, making it a valuable asset in any data-driven task. SpaCy is a leading library in the NLP landscape, particularly known for its robust named entity recognition capabilities. It comes with pre-trained models that recognize a wide range of entities like names, dates, and locations. However, when your application requires domain-specific entities, customizing the NER pipeline becomes crucial. SpaCy offers comprehensive support for building custom NER models by allowing you to adjust the pipeline components and train models on your specific datasets. This flexibility extends to integrating with other NLP tasks such as part-of-speech tagging and dependency parsing, making it a versatile tool for comprehensive text analysis. Understanding these capabilities sets the foundation for tailoring your model to recognize entities that are most relevant to your domain, such as medical terms or industry-specific jargon.
Generic pre-trained NER models, while powerful, often fall short in recognizing entities specific to niche domains. This is where custom NER models shine. By training your own model, you can recognize entities that are unique to your field, such as technical terms in engineering or specific product names in e-commerce. This customization leads to improved accuracy and performance, as the model becomes attuned to the language and context of your data. For instance, in the legal domain, a custom NER system might identify case numbers, legal statutes, or court names. In healthcare, it might recognize medication names, diseases, or medical procedures. The ability to tailor the NER system to your specific needs not only enhances recognition performance but also supports better data-driven decision-making in your applications.
Before diving into custom NER model training, it's essential to set up your SpaCy development environment. Start by installing SpaCy, which can be done using pip with the command pip install SpaCy. It's advisable to use a virtual environment to manage dependencies effectively. Once SpaCy is installed, you'll need to download the language model that best fits your needs, using a command like Python m SpaCy download n_core_web_sm for English. This setup includes essential components such as tokenizers and pipelines, which are crucial for processing text. Having a well-prepared environment ensures smooth development and testing of your custom NER models. Ensure that your setup includes all necessary libraries and tools to facilitate efficient model training and evaluation. The cornerstone of a successful custom NER model is a high-quality annotated dataset. Begin by collecting text data relevant to your domain. The next step is annotation, where you label entities within your text. Tools like Prodigy or Labelbox can streamline this process, offering intuitive interfaces for tagging entities. It's crucial to create a balanced dataset that represents the diversity of entities your model will encounter. This involves annotating a wide range of examples to ensure comprehensive coverage. Once annotated, export your data in a format compatible with SpaCy, such as JSON or CSV. High-quality, well-annotated data lays the groundwork for training a model that accurately captures the nuances of your domain.
With your dataset ready, it's time to train your custom NER model. Begin by initializing a new NER pipeline or modifying an existing one. You'll need to add your custom labels to this pipeline using SpaCy's API. The training process involves iterating over your annotated data to adjust the model's parameters, usually done through several epochs to achieve optimal performance. It's essential to monitor for overfitting, where the model performs well on training data but poorly on unseen data. Techniques like regularization or using a validation set can mitigate this risk. Once training is complete, save your model, making it ready for deployment. SpaCy allows you to save models with a simple command, ensuring you can easily load and use them in future applications. Evaluation is a critical step in the development of a custom NER model. Use metrics like precision, recall, and F1 score to assess how well your model performs. Testing on a separate dataset that the model hasn't seen during training provides insights into its generalization capabilities. To improve performance, focus on error analysis by examining false positives and false negatives. This analysis can guide further training iterations, helping you fine-tune the model. Techniques such as hyperparameter optimization or augmenting your dataset with more annotated examples can also enhance performance. Remember, model development is an iterative process, Continuous evaluation and adjustment are key to achieving high accuracy and reliability in your custom NER system. Deploying your custom NER model into a production environment is the next step. Integration involves embedding the model within your application's architecture, which could range from web services to desktop applications. Ensure your deployment environment is optimized for real-time processing, allowing your model to handle incoming data efficiently. It's vital to monitor the model's performance once deployed, as real-world data can present new challenges. Implement logging and performance tracking to capture how the model interacts with production data. Scalability should also be considered, ensuring your solution can handle increased loads without degradation in performance. By focusing on these factors, you ensure that your custom NER model provides reliable and accurate entity recognition in a live setting. Maintaining and updating your NER model is crucial for long-term success. Regular updates ensure the model adapts to shifts in language and domain-specific terminology, known as concept drift. Incorporating new data into your training set allows the model to learn from recent examples, maintaining its relevance and accuracy. Continuous performance monitoring is essential, highlighting when the model's predictions deviate from expected results. This monitoring can inform when retraining is necessary. Encourage collaboration by involving domain experts in the refinement process, as their insights can lead to significant improvements in model performance. By adhering to these best practices, you ensure your custom NER model remains an effective tool for entity recognition over time.
In conclusion, mastering custom NER models with SpaCy opens up a world of possibilities for tailored entity recognition. We've covered the importance of customizing NER systems, setting up your SpaCy environment, creating and annotating datasets, training and deploying models, and maintaining them effectively. These skills are invaluable for extracting meaningful insights from text data, particularly in specialized domains. As you continue to practice and refine your models, you'll find new ways to improve accuracy and performance. We encourage you to apply these techniques to your projects, unlocking the full potential of custom NER models in your applications.